I'm Reece Hughes from Bekaert. I'll be providing a technical overview of high-performance ropes with a focus on the Bryden brand of crane ropes. When selecting a wire rope, it can be a bit of a compromise when we need to consider strength, resistance to corrosion, abrasion, fatigue, and rotation. Within the crane rope market, we talk of three different types of constructions: single layer, multi-strand, and parallel closed. The basic components of a wire rope: a wire, a single element; a strand, a number of single wires twisted together; then a rope, a number of strands twisted together around either a core of steel or fibre. When discussing rope constructions, we generally talk in two types: single layer and multi-layer. In single layer, we primarily use an 8x26 and 8x31. Within the multi-layer, or non-rotating, we talk of 19x7 or 34x7. When selecting a rope for an application, we have to consider many things. In particular, flexibility and wear. This is a compromise between wire size and wire count within the strand. i.e., if we had a 6x25, it would have 12 outer wires at 1.47mm. If we had a 6x41, it would have 16 outer wires at 1.16mm. When we're selecting wire rope that requires flexibility and/or wear resistance, there's things to consider. So when we're looking for a rope that is resistant to abrasion, we try to increase the wire size in the outer strands. When we're looking for something that's resistant to, say, fatigue, we'll increase the wire count and reducing the subsequent wire size. As you can see on the diagram, the increase in wire count in the strands increases fatigue resistance. Conversely, the reduction in the wire count and increase in diameter improves abrasion resistance. Within crane ropes, we primarily talk of two different types of cores, and they're related to the two different types of ropes we've been discussing. So within stranded ropes, we talk about an IWRC, which means an independent wire rope core. Within multi-strand or rotation-resistant ropes, we speak of a WSC, which is a wire strand core. When selecting a rope that requires resistance to abrasion, we look for a diform or compacted rope. This provides greater surface area contact on drums, sheaves, and anything the rope comes into contact with. At Bekaert Australia, 98% of the ropes we stock are diformed or compacted, like our Diform Brightstar 8 or our Diform 34LR. When selecting a rope, there is also the importance of the lay direction of the strands within the rope. We have right-hand lay and left-hand lay. From there, we also discuss the lay of the wires within the strand. We have ordinary lay and Lang's lay. The lay direction of the strands and the wires is important due to the drum anchorage. For instance, if you stood behind the drum and had a right-hand rope and it was overlaid, your thumb is pointing to the direction the rope should start. So if I had a right-hand rope overwound on a drum, it would be anchored to the left, and then underwound would be anchored to the right. This is important, as due to the natural characteristics of the way the rope is laid, it will want to turn and generally behave better on the drum. And that's why there's great importance put in selecting right-hand or left-hand lay ropes. Rope grades and wire tensiles directly correspond to the rope's strength, or minimum breaking force. At Bekaert Australia, we carry three types of grades: 1770, 1960 or 2160. Our high-performance crane ropes are manufactured in line with international standards, from -0 to +5%. In certain applications where a tighter tolerance is required, we can manufacture from -0 to +2%. Abrasive characteristics. In addition to the diforming or compacting of ropes, we may look to adjust the lay direction of the wires within the strands, from ordinary lay to Lang's lay. As you can see in this diagram, the Lang's lay wires observe a greater surface area contact from the rope to whichever it's meeting, as opposed to the ordinary lay, where it tends to wear on a higher point and subsequently wear at a faster rate. Turn characteristics. When a rope is placed under load, it essentially wants to undo itself. This is observed as torque within the rope. For Lang's lay ropes, both the strand and the wire are laid in the same direction. This leads to higher torque. For ordinary lay ropes, the wire is laid in the opposite direction to the strand, which produces lower torque. A case for plastic. The major benefit of plastic within a rope is that the plastic acts as a cushion between the outer strands and the core, and therefore increases the bend fatigue life of the rope. At the same time, the plastic helps retain lubricant at the very heart of the rope. The increased service life performance is the most significant benefit, where change-out costs, including the cost of downtime, are high. Another plus point is the stability of the rope, assisted by the inclusion of plastic when entering or exiting terminations. The Diform Brystar 8 product is most commonly used within multi-reeved applications. It has many advantages, including lubrication retention, minimising strand-to-strand contact, and increased bend fatigue. Rotation-resistant ropes. Rotation-resistant ropes, or non-rotating ropes, are most commonly used in main hoist or auxiliary hoist applications. The rope is produced where the inner strands are laid in the opposite direction to the outer strands. As load induces torque, this construction of rope is required in hoisting to avoid the load spinning or moving during lifts. At Bekaert Australia, we carry a range of 34LR and 34LR PI non-rotating ropes. Thanks for listening. I hope you found it informative. For further information, please contact us using the details on the screen.